Arterial blood pressure determines how much blood flows into the capillaries, where the exchange of nutrients and wastes between blood and body cells occurs. If the pressure is too low, not enough blood goes into the capillaries. If the pressure is too high, blood vessels can break, causing internal bleeding and possibly strokes. The aortic arch and common carotids are arteries that supply blood to critical areas of the body. The aortic arch supplies the body, and the common carotids supply the head. Within these major arteries are structures called baroreceptors that measure blood pressure and send nerve impulses up to the brain. If pressure is high, the walls stretch. If pressure falls, the walls are less stretched. Baroreceptors send information to the cardiovascular center in the medulla oblongata in the brain. When blood pressure drops, the slower rate of impulses from the baroreceptor conveys this disruption to homeostasis to the CV center. The CV center sends its own nerve impulses out to the heart and many of the blood vessels. The heart starts to beat faster, sending blood to the arteries at a faster rate. It also beats with greater strength, sending greater amounts of blood to the arteries with each beat. The nervous signals from the brain also signal secretion of hormones that constrict blood vessels, increasing their resistance. As the pressure of the blood in the arteries goes up, the change is detected by the baroreceptors that send the information about the restored blood pressure up to the brain. When the brain receives this response, it will cut back on its stimulation to the heart and blood vessels because homeostasis has now been achieved.